Alright, so for this one, it's just an air track glider. It's of mass M. Consists of two smaller connected gliders, and then a small explosive charge is connected between them. The explosive goes off, and then you have a system of two gliders now. Okay, so the system is initially moving to the right at 2 meters per second, and then one after it's detonated, the smaller glider, in this case, which is 16M, moves to the right at a rate of 5 meters per second. It wants us to find the speed or the velocity, excuse me, of the final velocity of the second glider here in red. So I'm just going to go ahead and identify my masses. The problem gives me the small glider, which in this case is green. I will label that as 16M. It's in the problem here. And then I can go ahead and find the mass of the red glider. To find the mass of the red glider, I can just make the statement, mass of the red glider plus the mass of the green glider equals to the mass of the system, which in this case is just capital M, because the the mass of the smaller glider is given as a fraction of capital M, implying that M is the total mass. Okay. All right. So to solve for M red glider, we would just subtract both sides by mg. Mg here being mass of the green glider, and then once you have that, you can just substitute out mass of the green glider for the given fraction, which is 1/6 capital M. And as you can see here, you have a term M minus 1/6M. So therefore, you need to find common denominator. So the common denominator here would be 6. So you need to multiply this total system of M here, top by 6, bottom by 6. Therefore, now you have common denominator. So 6 minus 1 is 5. And then the common denominator on the bottom is just 6. So mass of the red glider would be 5/6 of M, which makes sense, right? Here is 1/6. The remaining mass has to be the leftover, which in this case is 5/6. Because 5 plus 1 is 6. 6 over 6 is 1, which is the total mass of the system. All right, now that we have the mass of the red glider, and we have the mass of the green glider, and then we have the final velocity here of the green glider as 5 meters per second, we can solve for the final velocity of the second glider, which in this case is red. All right, so I'm going to set up conservation momentum here, and then I know initially the system is moving as 1, so therefore it's just whatever mass is of these two things combined, which is just called capital M. And then I want to break the right side of the momentum statement into two things. After the detonation, you have two objects moving. Here, 1/6 of M is given to be moving to the right at a rate of 5 meters per second. We already found the remaining mass, which is the mass of the red glider, which is 5/6M. The only term I don't have here is the final velocity of the red glider, which is essentially what the question is looking for. So let's go ahead and cancel stuff out. M appears on every term, so I'm just going to cancel it out. VI is given as 2, and it's a positive 2 because it said so. And then here, V green, F, so the final velocity of the smaller green glider is given as 5 to the right, which is positive. The diagram said so, and the statement here is just right at 5 meters per second. All right. I don't know what VRF is, so I'm just going to clean this up a little bit. So if you watch where I'm circling here, the first term on the right side of the equal sign is just 1/6 times 5, which is the same thing as saying 5/6. But then algebraically speaking, if I need to get VRF by itself, the first thing I need to do is combine like terms. So I'm going to move this positive 5/6 to the left side so I can combine it with 2. That'll change sign. So it'll actually be 2 minus now 5/6, because don't forget when you move terms, the sign changes. Okay. All right. So here we have 2 minus 5/6, which is equal to just 5/6 VRF. The second term on the right, I haven't done anything. I just carried that down. So I'm going to keep cleaning up this up a little bit. Here's 2 minus 5/6. So you need to find common denominator. So the common denominator here is 6. So you multiply 2 by 6, and that would be divided by 6 as well. So therefore, 2 times 6 is 12, divided by 6. Which makes sense, right? 12 divided by 6 is 2. We do this just so we have a common denominator. Here, 12 minus 5 is 7. And then the common denominator here on the bottom is just 6. So it will be 7 over 6. And the right side I haven't touched, so I just carried it down. But I notice here I have 7 over 6 and I have 5 over 6. So I'm just going to actually cancel the 6's out. So really, to get VRF by itself, I would need to get rid of this 5 that's in the numerator. So to do the opposite operation, I would just need to divide. So really, you move this numerator 5 to the bottom left. So your answer is going to be at the top here, 7 over 5 meters per second. And I've chosen to include the positive sign here because my calculation shows that after the collision, or excuse me, after the detonation, the red glider actually moves to the right at a rate of 7/5 meters per second. You can reduce down to fraction if you want, a decimal if you want, but I'm just going to keep it as a fraction, okay? So the positive sign here, because it says final velocity, which is a vector, so I'm going to include that positive sign. All right, other than that, stay nerdy, don't be whack.